we're told that figures A and B are scale copies. And the first thing I'm going to ask you is, what is the scale factor from figure A to figure B? Pause this video and try to figure that out. Well, let's look at two corresponding sides. So if we look at the bottom side of these triangles, which look like they are corresponding, we can see that figure A has a length of 4, and figure B has a length of 2, 4, 6, 8. So we are multiplying corresponding sides by 2 to go from figure A to figure B. We could do that with the other sides as well. So the scale factor for figure A to figure B is 2. Now, what if we were to do it the other way around? What would be the scale factor from figure B to figure A? Well, if we multiply by 2 to get to figure B, a corresponding side, if I'm starting with figure B and I want to get to figure A, I would multiply by the reciprocal of 2. I would multiply by 1/2. I would take this 8 and multiply by 1/2 to get to that 4. So this is going to be equal to 1/2, the reciprocal of 2. Let's do another example. Here, once again, we're told that these two are indeed scale copies. And let's figure out the scale factor. I just won't write it out. Scale factor of figure A to figure B. So same exercise. Pause this video, try to figure that out. Okay, so when we go, if we look at corresponding sides here, I'll go from this left-hand side. We're going from 2 to 1/2. So what do I have to multiply to go from 2 to 1/2? 1/2 is 1/4 of 2. I have to multiply by 1/4. And we can see that with the other sides. If I multiply this by 1/4, I get to 1/2. If I multiply 3 by 1/4, I get to 3/4. So the scale factor is 1/4. Now what if we were to do it the other way around? What is the scale factor from figure B to figure A? Well, as we just saw, it's going to be the reciprocal of that. If we multiply by 1/4 to go from A to B, we're going to multiply by 4 to go from B to A. So this is going to be 4, the reciprocal of 1/4. They are the reciprocals of each other.